Hi all, good morning to everyone. Do you have any doubts? Whatever we have discussed in the last session, have any doubts in the last session?
No, sir.
Okay, today, right, let us consider this as a semi-lab session. In this session, I give you the list of exercises. I explain what you need to do. You have to solve the exercises and you need to share your screen and explain how you have programmed. I explained the list of exercises, right, that you need to complete in this session. First one, you need to write a program to compute x power n, in which x and n are inputs. Inputs are x and n. Assume x is a floating point quantity and n is the integer one. X is a floating point number and n is an integer one. Suppose x is equal to 3.0 and n is equal to say 4. You need to print the result as x bar n, this is equal to 3 bar 4. You need to print the result as 81.0. So how to write a code? You need to use the control statements, use the for loop, while loop, a do while loop, whichever is easier to you. Using that, right, declare the variables, get inputs x and n, find the computation, store the result in some variable, and print the result. Second one, addition table for n. We solved, right, the same problem for multiplication. Suppose n is equal to 5 is given. What you need to print, for example, 0 plus 5, this is equal to 5. Then addition table, right? So 1 plus 5, this is equal to 6. 2 plus 5, this is 7, etc. What to write, you can control through the number of rows you want. For example, 25 plus 5 is equal to 2. This is the required output. Input is, for example, n is equal to 5. Expected output looks like in this form. Have any doubts? Third one, check if the given number is strong or not. Problem is checking if the given integer is a strong number or not. A number is strong if it is equal to the sum of the factorials of its individual digits. For example, input, say n is equal to 145. We need to check if 145 is equal to 1 factorial plus 4 factorial plus 5 factorial. So 1 factorial 1, 4 factorial 24, 5 factorial 120. So it seems 145 is equal to, right here, 145 in the factorial sum. If it's so, the given number is a strong number.
Sir,
Yes,
sir, what do you mean by strong number, sir?
and that's what I am explaining. If you input n is equal to 145, you need to find the sum of the factorials of its individual digits. So when n is equal to the sum of the factorials of its individual digits, then it is said to be a strong number. Suppose n is equal to 102. 102, this is not equal to what one? 1 factorial plus 0 factorial plus 0 factorial plus 2 factorial. So this is not a strong number. Clear? Clear or not?
Yes, sir.
So if possible, right, you try to define functions. So it is better to define functions, right, for all these exercises. So that you can call a function with the required number of parameters, receive the parameters in the formal parameters list carefully, and define what are the operations to be performed in the function, and decide, right, if the function would like to return the result to the calling place. If not, if you want to process everything within the function definition itself, process everything there itself and print the requirements.
Sir, is functions there for the exam, sir?
I think, right, the syllabus has not yet fixed, right. Once it is fixed, I will inform you. Even, right, you can solve the problems using functions or without functions. You can write everything inside the main function, or you can write simplify the task. For example, in this case, how will you find the factorial, right, thrice, or if the given integer n is a 5-digit number, how can you find the factorial, right? So that's a difficult process. So try to define functions, right? Normally, C is a structured programming language. Complex problem can easily be split into a set of functions. So try to write functions and familiarize the structured programming concepts in a C language. Even in case, right, for example, if functions are not a part of your first test, you need not worry about, right? You can solve the problems also using functions. Clear? Any doubt? The fourth one, check if the given integer is a 3-digit Armstrong number or not. Check if the given integer is a 3-digit Armstrong number or not. This is the problem. So how do we check if the given integer, say a 3-digit integer, is or have, right, given a 3-digit integer? 3-digit integer is an Armstrong number or not. If you take, right, a 3-digit number, say 153, n is equal to 153, you need to find this operation. 153 is equal to 1 power 3. I use, right, this notation to have a power. 1 power 3 plus check if 5 power 3 plus 3 power 3. So why should we take, right, power 3? If it is a 3-digit number, right, power 3 should be taken. In case if it is a 4-digit integer, power 4 should be taken. So check if the given integer is equivalent to 2. Sum of the powers of, right, individual digits with respect to the power values, the total number of digits in the given integer. Suppose if you take, right, 1, 2, 3, 4, you need to check if 1, 2, 3, 4 is equal to 1 power 1, 2, 3, 4 is a 4-digit number. So check this operation: 1 power 4 plus second digit 2 power 4 plus the third digit 3 power 4 plus fourth digit 4 power 4. So in case if this is equal, right, then you can conclude this is the 4-digit Armstrong number. I mean, right, 1, 2, 3, 4. But 1, 2, 3, 4 is not a 4-digit Armstrong number. This is not a 4-digit Armstrong number. But 153, right, you can verify. This is 1 power 3 plus 5 power 3, right? 125, 3 power 3, 27. So 152 plus, right, 1 power 3, 153. This is the, yes, the 3-digit Armstrong integer. So how do we check? We have solved, right, several problems by processing the individual digits of the given integer. So you know well, by performing the modulus 10 operation, subsequent, right, division operation, we can extract the digits of the given integer. Once we extract the digit of a given integer, try to find its cube. Right? For example, in this problem, assuming the given integer is a 3-digit one, so input a 3-digit number. After extracting the individual digit, try to find its cube and update a variable sum. Then extract the next digit, update a variable sum by finding its cube. Then extract the next digit, abstract a variable sum by finding its sum of the digit of that cube, sum of the digit, right? Then check if the variable sum variable is equal to original n. So try to keep the value of n in another variable because you will be subdividing the value of n by 10. Then check if the given integer is equal to the sum result that you have obtained. If it's so, then it is to be a 3-digit Armstrong number. Otherwise, it is not a 3-digit Armstrong number. Understand the fourth one? Have any doubts in fourth one? Fourth one, have any doubts? Okay, then the fifth one. Print, right? You need to print these things. Upper lowercase alphabets with ASCII values. Capital A, you need to print the result like this. Capital A, what is the ASCII value? 65. Then capital B, 66, etc. Capital Z, 90. Then small a, 97. Small b, 98. Then the small z, 122. So simply write, if you run the program, you need to print both uppercase and lowercase alphabets and print their ASCII values also, right? Within bracket or put hyphen and print the values, alphabets. Okay. So using the for loop or while loop or do while loop, and initialize the character and print its equivalent integer value using type conversion, or simply print use the percentage %d format specifier to print the integer equal. Then sixth one, find the sum of the digits at odd and even places of the given integer. Again, this is the problem. Suppose n is 1, 2, 3, 4, 5, 6. You need to find the sum of the digits at odd places. Odd places sum. Not places sum, right? That means 1. Then a third position is 3. Then a fifth position is 5. 1 plus 3 plus 5. This is 9. Then even places digits sum. Even places, right? Say second position 2 is there, fourth position 4 is, and the sixth position, say suppose here is 0 is, sixth position 2 plus 4 plus then 0. This is equal to 6. This you need to print. Further, the program, right, can be extended, right, to check for divisibility of 11. So if you find the odd places sum and even places sum, and the difference is 0 or multiple of 11, ultimately the given integer is divisible by 11. So in this example, right, you try to find, right, as I asked, find the sum of the digits, right, at odd places and even places separately. Then seventh one, right, starting from 7, right, we have some pattern exercises. These can be solved using the control statements. Half pyramid of star. Suppose input is, for example, n. Number of rows to be printed. 1, 2, 3, 4, 5. Having the input n is equal to 5. The expected output is this one. First row you should have exactly 1 star. Second row 2 stars. Third row 3 stars. Fourth row 4 stars. And the fifth row 5 stars. These pattern problems can be solved using for loops, while loops, or do while loops, or simply control statements. Even you can use the nested control statement. You can place a control statement inside another control statement. So by nesting the control statements or looping statements, you can design the logic to print the required result. Then the next one, half pyramid of numbers. Suppose input n is equal to 5. In this case, the required output looks like in this form. First row right, you should print exactly 1. Second row right, 2 numbers, 1, 2. Third row right, 3 numbers. Fourth row, 4 numbers. And the fifth row, 5 numbers. This is half pyramid of numbers. Next, half a pyramid of alphabets. Input for n is equal to 5. The expected output is first row having only one alphabet, second row right twice the second alphabet, third row right thrice the third alphabet, fourth row 4 times the fourth character, fifth row right 5 times the fifth character in the alphabet, right? A, B, C, D. This is half pyramid of alphabets. Tenth one, whatever you have seen right in these exercises 7, 8, and 9. This can be reverted. So in the seventh one, if you input n is equal to 5, this is expected in the first row, this is expected in the second row, this you need to print in third row, print this structure in fourth row, print the star in the fifth row. That is said to be inverted or reverse half pyramid of star. Exercise number 10. Put n is equal to 5, input n is equal to 5, print the result in this form. First 5 stars, then 4 stars, 3 stars, 2 stars, 1 star. Likewise, inverted half pyramid of numbers. Have an input n is equal to 5 and print the result in this form. 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 1, 2, 1. Combining the half pyramid and the full pyramid, we can have sorry, half from it, right? Extending the half from it, right? Twice we can have this structure when n is equal to 5. It's the formatted one, right? So center portion 1 star, then second row, right? 3 star, third row, right? Here 3 plus 2, 5 stars. Then this is the fourth row, and this is the fifth row. So if you input n is equal to 5, which determines the number of rows to be entered. How many number of rows are required in the output? That is determined using the input n is equal to 5. Likewise, a full pyramid of numbers. Here input say n is equal to 5. Number of rows to be output. The output is 1, right? This is the first row, second row, third row, fourth row, and fifth row. And the last one, this is Pascal's triangle. Input the number of rows n is equal to 5. Output looks in this form. 1, okay, what is this n? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Input is n is equal to 6. 6 rows. Again, this is the number of rows to be printed. First row, second row, then the third row, then this is fourth row, fifth row, sixth row. How to find this one? First one, 1, right? You need to print these two rows. Then 1, add these two, 1 plus 1, 2. Then print the number, right? 1 as it is. Then 1, adding this 1 and 2, right? You will get this 3. Adding the next two numbers, 2 and 1, you will get 3. Then order numbers, right? The right as it is. Next row, 1 plus 3, right? This is 4. 3 plus 3, this is 6. 3 plus 1, 4. Then border numbers 1 and 1 as it is. Last phase 4 plus 6, 1 plus 4, 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5. 1 as it is. So this way you need to control through the for loop, while loop, do while loop are nested control statements to print the required output format. If you have any doubts in solving these exercises, okay, now I post the exercise list in the GCR. What we have to do, you can use any compiler, online compiler, or you can use right the Turbo C++ or C++ 4.5 compiler. Once you have completed that exercise, what you have to do, right? You need to share your screen and you need to show how you have solved the exercise and run the program so that we will verify the correctness of the program. In case if you have any doubt, right, compilation errors or some logical errors, please share your screen, right? We will solve the issue. Let me share the let me post this exercise list in GCR.